And our last speaker in this session is Tyler Pritchard, talking about across and how NASA are helping to improve infrastructure for multi-messenger astronomy.
Yeah, I wanted to thank the organizers for letting me be here and all of you for staying to the very end of the meeting. This is great. I'm a research scientist at the University of Maryland, and one of the hats that I wear that I'm really excited to talk about with you today is my NASA hat, where I get to work as a support scientist on the Astrophysics Cross Observatory Science Support Pilot. And that is a lot of words. But basically, I'll give you a little bit of background about the pilot and what that actually is, how it came to be, what our sort of vision and mission for it is, the kind of core work that we're trying to do, the status and schedule of it, and then I'm going to do our rep for our own little fourth TDAM workshop that's coming up in the fall of 2025. And I want to highlight that really it's a multi-institute kind of thing. We're spread out across a bunch of NASA centers and some not NASA centers, and are drawing from a wide variety of expertise from high energy mission PIs to TDAM infrastructure experts to just some very talented software developers, and then some people like me who somehow snuck in. And so for those who aren't familiar with the intricacies of random bits of US bureaucracy, in 2020, every 10 years, the US National Academies basically does a survey that says, hey, what do we think the important science cases are for the next 10 years in astronomy? And this effectively becomes a policy document that the funding agencies take very seriously because it's kind of a unified view from senior scientists that has community feedback about what, the important things are and what the challenges that the field are facing and what sort of we're maybe not doing as well as we can but should do better. So it's an important way to provide feedback from the scientific community to the funding agencies. And then in the way of government agencies, in response to this policy document, which was released in basically just about 2022 because 2020 something happened, who knows? We just NASA, the recommendation of that decadal survey was effectively that TDAM science is going to be big in the next 10 years, and NASA and NSF need to be doing more to enable that TDAM science. And so as a result of that, NASA basically conducted a study that said, okay, given what was laid out in this document, which is we don't have a link here, but it is all publicly available, and you can actually just read that if you Google decadal survey or after 2020. It'll show up. And basically now said, okay, given the statements in this document, what can we do to really enable TDAM science? And the outcome of that study was this Astrophysics Cross Observatory Science Support Pilot, or ACROSS. And the idea behind it is it's really going to enable a whole fleet approach to NASA TDAM by providing an organizational workforce and technical infrastructure. But we're looking not only at NASA's currently operating missions, but also new missions that are in development and coming online soon. And we're trying to make sure that what we're doing is not so siloed to NASA, that we're really enriching the broader TDAM infrastructure and ecosystem. And that's part of the reason why I get to be here today to talk to you all. That's explicitly part of what we're trying to do. And so we have a paper in 2024 that's kind of outlining this in a little bit more detail about what this pilot was scoped to do. Yeah. And so really, what we're trying to do is we're partnering with missions on the sort of internal side of NASA and observers outside of NASA and science teams across multiple astrophysics domains to make sure that the astrophysics scientific return of NASA's contributions to TDAM are as maximized as possible, so that we're really getting as much out of NASA's fleet of satellites as we can. And so that's a lot of words to say what we'd like to do, but the question is, how are we actually going to do it, right? And we've kind of narrowed it down into 4 different sort of plans of work. And there's a lot of overlap with some of the ACME work plans, actually, I would say as well. And so the first is the most technical one, which is the sort of science feasibility tools that we've been developing, as well as the modern target of opportunity resources. And then we're working on a sort of NASA-focused TDAM web portal so that users can more easily access some of these things. And then a community engagement and innovation program, where we're really trying to make sure that we're responsive to the community, that the community knows what we're doing, and that we're hearing what is working for the community and what's not. And so when we talk about science feasibility tools, what we are really starting with is the idea of state and status information for the NASA fleet. And so this is going to involve things like creating standardized interfaces for pointed and wide field instruments, so we can have things like long and short-term observability plans, as well as historic observability plans for both specific targets and kind of positions on the sky. So we have target visibility and observability calculators that's more easily checkable to see what the sort of joint observability for a point on the sky is between two NASA missions. We want to make sure that we are building in things like constraints on planning and scheduling feasibility for these, so that when missions go to schedule things, they can sort of quite rapidly and responsively let you know whether or not these things are going to be feasible. And mission target history, so we know that where these things have historically observed. And I think this is really trying to get back to Susanna's question from this morning about, like, how do I know what data exists for a target on the sky? And we're not going to be able to tell you what all of the data that exists, but we are trying to make it at least easier for you to know what NASA data exists. And I should highlight that this is all meant to be accessible through open source JSON serializable APIs. So you can build this into your favorite tool chest or website of choice and get this access to this in a sort of scalable way. We're also working for sort of value-added applications for wide field instruments. So whether an event of interest was coincidentally detected, and when was the last time a source was detected inside of a field of view, or that sort of thing. So really trying to enable some of these rapid response TDAM concerns. And while we are NASA focused and are trying to support the NASA fleet, we're also trying to make sure that what we develop is as generalizable as possible, so that we can have analogous capabilities for ground-based where feasible, such as perhaps for some of the target visibility, or that we're sort of playing nicely with externally developed services and incorporating them where feasible. We're not going to be able to do everything on our own, but we do want to make sure that we're interfacing with things like NSF-AON and other infrastructure packages as much as possible. And this is going to be all available as open source software on GitHub and deployed as web applications. So we'll have both our backend server, our science-oriented toolkit, and a lightweight SDK for building this up into your own applications available on GitHub. The other thing that we're trying to do is basically develop some new modern target of opportunity resources. So one reason that NASA missions can have a hard time responding to TDAM requests is that, quite frankly, TOO infrastructure and TDAM infrastructure can be expensive to build. And if your mission's primary science isn't oriented around that, particularly for small missions, you might not have built this infrastructure. And so one of the things that we're working on is basically TOO resources that will enable NASA missions, particularly smaller NASA missions, to roll out sort of responsive TDAM capabilities in a more easy to use and lightweight way for them. And so we've actually already done this once for a CubeSat that it has sadly fallen back into the Earth's atmosphere, but it was a broadly successful sort of proof of concept that we're hoping to extrapolate to more missions in the future. And part of this is going to be a sort of TOO toolkit that should be an open source Python software toolkit to assist in sort of planning and executing TOO requests that we hope missions will find useful. There's also going to be a web application, so a sort of front-end web interface to use with the TOO API, that you can submit things programmatically through the API or as a user on a web page for missions that have sort of chosen to opt into this TOO infrastructure. And then we are also working on developing a web portal. That web portal is going to be a mix of things. It's going to have some sort of lightweight informational content that's going to be sort of NASA-focused TDAM things about funding calls and workshops and mission updates and this sort of thing. And we'll have a link to mission and external tools and resources. So if you feel that your TDAM mission or external tools and resources would be interesting here, feel free to let us know. We're also going to have dynamic content, which is effectively going to be these web portals to our TOO and our visibility calculators and observability calculators and schedule histories and that kind of thing. And then we're going to have a help desk. And that help desk is really going to be for both internal and external to NASA. One thing that we kind of envision ourselves potentially doing is basically helping coordinate these joint observing programs or TDAM observing programs where speed and multiple wavelengths, multiple missions are crucial. And so we're sort of both a resource that the observers can reach out to us for being like, hey, I want these observations. What's the best way to put in the requests? And also that the missions can to basically help us understand what the observers really need and what we're doing. And I'm going slow. So I do want to highlight, we also have a lot of community engagement plans. One is the TDAM workshop. So part of our plan is organizing and supporting TDAM workshops. We've already done several, and this is planning on being kind of an ongoing thing where we're really trying to facilitate and explore the definition and implementation options for enabling community science cases, as well as having some like tutorials and training on sort of across tools and TDAM tools. We are hoping to offer some funding opportunities that is perhaps less relevant for the international community, but we do hope that they exist, subject to funding availability. And we really, again, want to make sure that we are participating in external and community-led initiatives, that we hear what you need from NASA and NASA's fleet, and that we are able to provide you with that. And try to make sure that we're as interoperable with external tools and infrastructure that are being developed as possible. And so our status is we are basically implementing everything on GitHub right now, and we're working through NASA's open source software release process. So what that means is that, well, this is on GitHub, I can't show it to you yet, but we anticipate everything being open source and visible by our workshop in October of 2025. We have some little mock-ups of what our layout works like. It's going to be a pretty website, hopefully, somewhere. Again, I can't show you this yet. We're on track to have everything visible sort of in about October 2025. There's going to be a variety of things in terms of like onboarding missions and visibility calculator tools. We'll start with a couple of NASA missions, and the plan is to onboard more over time as we see what works and what doesn't. And really, I want to advertise our 4th TDAM workshop. And the theme for this is basically we want to come up with community-defined coordinated observing concepts for rare and important transient events. So when the next 1708-17 goes off or the next boat GRB goes off, we don't want to have the NASA flagship facilities waste time trying to figure out what the best observing strategy is, what the appropriate follow-up is. We want to have things that are defined that we can bring to them and be like, hey, this is what we need to pursue the science case. Don't spend the time trying to figure this out. Let's just get on these targets as quickly as possible. And we want to do this. We want the community to do this, not us. So that's what the workshop is about. It's going to be hybrid. So I encourage all of you to either visit or call in. And actually, a lot of the work is going to be going on in Slack ahead of time, where these things are going to be argued out in probably glorious detail. And I should say that while I'm headlining NASA here, we're hoping for this to be more than just NASA. We've had some interest from other facilities, from ground-based radio and optical, fairly large facilities. And so if that works out, this will be a broader package that we're really bringing to the facility stakeholders, saying that, we want to minimize response time and maximize science. And for these very rare cases where we can't afford to get it wrong, this is what we need to do. And so I will leave it there, but thank you very much for staying.
Questions from the audience or online?
Thanks a lot. It's really extremely interesting. Just a very quick confirmation about the time scale. So you mentioned October, the launch of GitHub and the website. Is that also the time scale for the APIs to become online and
yeah, the plan is to
functional?
have the APIs accessible in the end of October for some small fraction of missions, and then we'll roll out more missions over time. That small fraction of missions might be something like 1, it might be something like 3, but a few, and then we'll scale up from there.
Great, thanks.
I don't think you said it. Which missions do you think you're going to start with?
I think we're going to start with something like TESS, Fermi, and Swift. Yeah. We're in discussions with some smaller missions that are launching soon as well, and so it depends on what turns out to be the easiest to start up and what we have the most mission buy-in from. I would say that's still very subject to change depending on how things go. Yeah.
A question from me then. It was interesting to see you'd mentioned this was all highlighted as a priority during the last decadal in 2020. I guess potentially an awkward question. What happens after the next decadal, and how long do you envision this project running for?
That's a great question. I dearly hope that TDM is still interesting in the next decade, even if it's not highlighted as such an important decadal scope. From a NASA side, we never know for sure. Things always can change. I would say that our expectation is that upon the end of this pilot initiative, we'll be rolled over into something like a guest observer facility or a archive type facility where every 3-ish years we'll undergo some review and feedback process where, funding contingent will continue funding as long as we are meeting a need that the community has and delivering good science. Asterisks, who knows? But things like NASA HESARC and ExoFOP and a broad range of scientific facilities in this vein have been funded for long periods of time. So I don't think we're done in 5 years.
If there are no further questions from the audience, then we will move on to